Hello friends, in this video we'll learn a very important property of continuous time impulse signal which is called as a product property. Let us begin. So let us start with this product property. As you can see, there are total 4 questions which we need to solve. First question says x of t dot del of t, then x of t dot del of t plus beta. Thereafter x of t is multiplied with del of t minus beta. And the last question says x of t multiplied with del of alpha t minus beta. Let us solve one by one. Let us start with a very first question which says x of t dot del of t. So first question says x of t dot del of t. So let me tell you, x of t can be some arbitrary signal which we can assume, which is now multiplied with del of t, which is unit impulse continuous time signal, right? So let us see. Let us assume some arbitrary x of t here. Let us assume lower limit of the signal is -1, upper limit is +1, and this is 0 with respect to t. So some arbitrary signal x of t is drawn with respect to time, and let us assume now this is getting multiplied with del of t signal, which is unit impulse signal. We know that how unit impulse looks like. It is present only at t equal to 0. When t is not equal to 0, it is 0, having unit area. So we write 1. Remember that 1 I have written is not the amplitude. Amplitude is infinity. Area is equal to 1. So such signal is what we call as unit impulse signal. Now imagine if these two signals are multiplied. Think about this area which says for t less than 0. So for t less than 0, since del of t signal is 0, therefore 0 multiplied by anything will remain 0. And again over here, that is t greater than 0 area, again del of t value equal to 0. So anything again multiplied with 0 will remain 0. So I'm just giving you a final product. So for t greater than 0, you will get nothing. For t less than 0 also, you will get nothing. Only at t equal to 0, x of t gets sampled. So we don't know what is the value of x of t at t equal to 0, but in general, I can write this as x of 0. Am I right? So this x of 0 is getting multiplied with this impulse signal. So of course, you will have some impulse signal only present at t equal to 0, having area as x of 0 now. Is that right? So this is what the graphical representation is, okay? What I need to write a mathematical expression for the same. So I'm just going to write as x of 0, because x of 0 is what we called as area of the impulse signal present at t equal to 0. So I can write this as del of t. So now this has become very simple. If this is the question, which is x of t dot del of t, x of 0 dot del of t is the answer, where x of 0 is called as area. So we know that this is in fact called as area or strength of the signal, and this del of t basically indicates position of the signal. So whenever any x of t gets multiplied with any impulse function in any form, you get your answer in two things. In first part, you get strength. In second part, you get position of that signal. So you don't have to really go through all this procedure. You can remember something like this. So I'll tell you the shortcut to remember. When x of t is multiplied with del of t, ask a question to yourself. This del of t is present at what time interval? We know that. Not exactly time interval, but del of t present only for a time instant at t equal to 0. So whichever time instant this is present, substitute that t value in this x of t expression. Is that right? Again, once again, del of t is present at t equal to 0. So substitute t equal to 0 in x of t. In effect, it becomes x of 0, and keep this del of t as it is. And that becomes your final answer. So you have to do in similar way for rest of the questions also. So let us go for the next question, which says x of t dot del of t plus beta. Second question says x of t is multiplied with del of t plus beta. Is that right? Now, let us not get into graphical solution. Just understand where del of t plus beta does exist. Of course, it is present at t equal to minus beta. Is that right? In fact, if you actually draw this, it is a impulse signal present at t equal to minus beta. Then, since this is present at t equal to minus beta, I'm going to substitute t equal to minus beta in x of t parenthesis. That is, argument of x of t will be replaced with minus beta. In effect, it becomes x of minus beta dot impulse signal is going to remain same, where del of t plus beta. Again, this is the final answer, where this indicates area of the impulse signal, also called as strength of the impulse signal, and del of t plus beta gives you position of the signal. So last time I'm going to draw the graphical representation of the same. It will be like this. Some impulse will be present at minus beta, having area as x of minus beta. Is that right? So finally, whatever I have drawn is the final answer in graphical form, and this is a mathematical form. Let us begin with the next. I'm sure you are now able to do this by your own. X of t is getting multiplied with del of t minus beta. So we know that del of t minus beta is an impulse signal present at t equal to positive beta. So just substitute t equal to positive beta in x of t. So ultimately we'll be getting x of beta dot impulse signal is going to remain same, t minus beta. Finally, this is what we called as a strength, and this is what we called as a position of the signal. Is that right? Let us move ahead with the next question. Now it is x of t is getting multiplied with del of alpha t minus beta. As you can see here, in this case, scaling is also done. Is that right? In that case, we know that how to take care of it. First of all, I'll copy this x of t as it is dot del of. We know that we make t coefficient free. In order to do so, take alpha common. What remains inside? T minus beta by alpha. Is that right? So we know that we need to first of all scale by alpha. So this is something which we have already learned. I'm sure you remember this. When you have del of alpha t, this is always equal to 1 upon mod of alpha del of t. So you have to use this knowledge and you have to solve this. So now this is equal to x of t dot 1 upon mod of alpha del of t minus beta by alpha. Is that right? Finally, this is the impulse signal, okay, present at t equal to beta by alpha. So we are going to substitute t equal to beta by alpha in x of t argument, that is over here. Now I can write x of beta by alpha dot del of t minus beta by alpha, and 1 upon mod of alpha, I can write it over here because this is ultimately constant only, right? So now this becomes the final answer. This is what we called as strength of the signal, that is strength of impulse signal, and this is position of the impulse. So now this has become the final answer. So I'm sure now for any possibility you can get the answer. We can take one more problem over here. I can go for like x of t dot del of, let's say, minus alpha t minus beta, and I'm sure now you're able to do this. What we are supposed to do? X of t dot del of, I'll take minus alpha out. What remains inside? T plus beta by alpha. We know that time reversal property doesn't affect delta signal because delta signal is a even signal. So we can rewrite this as x of t dot del of alpha t plus beta by alpha only. So I have removed the effect of alpha. Again, by scaling property, I can write like this: x of t 1 upon mod of alpha del of t plus beta by alpha. Now, where this delta signal present, it is present at t equal to minus beta by alpha. So I can substitute it over here. Okay, so I can write now final answer as 1 upon mod of alpha x of minus beta by alpha del of t plus beta by alpha. Finally, this thing gives you strength of signal, and this second part gives you position of the signal. So I'm sure you have understood this product property of impulse signal, which is very important while solving the problems on integration. You may require to use this product property. Thank you.